Welcome back to Roland Tutoring. If this is your first time joining us, please take a moment to hit the subscribe button. Feel free to contact us to have your problem solved on the channel or to reach out about tutoring inquiries via any of the methods listed in the video description. Today we are working on a fluids mechanic problem, and the problem statement is as follows. A rigid cylinder, the inside diameter is 15 millimeters, contains a column of water 500 millimeters long. What will the column length be if a force of 2 kilonewtons is applied to its end by a frictionless plunger? We're assuming no leakage. So I went ahead and did a little drawing here, which you'll want to do as you're doing your homework, just to show the existing condition of we have the length of 500 millimeters of water here. Here we are showing a 2 kilonewton force on this water, and we are going to find the second length. So the first thing we'll want to do is find our pressures. That is how we relate most things in fluid mechanics. So the first one, since there's nothing pushing down here, our pressure 1 will actually be 0. And keep in mind our pressure equals force over area. So we have no force, so our force would be 0, so therefore our P1 is 0. Our P2 is our 2 kilonewtons over, now we have to find the area of this. So if you recall, the area of a circle equals pi r squared. So we can go ahead and put a pi here. Our diameter is 15 millimeters, which would mean our radius equals 7.5 millimeters. And since most things are listed in meters, a lot of times that's just easier to solve to give us the right units here. We're going to go ahead and convert that to 0.0075 meters squared, or meters, not squared, sorry about that. So we can go ahead and put that down here, 0.0075 meters, and then we'll square that. So we can go ahead and plug that into our calculator here. And I'm going to go ahead and do the bottom first, just to make sure I don't screw up that part. Squared times pi. And we have 2 divided by that gives us 11,317.68, or we can round up depending on how you are doing that. I'm going to go ahead and just store it in my calculator to have that answer, but our pressure 2 here, go ahead and write that down, is our 11,317.68 kilonewtons per meter squared, which is also equal to 11.318 MPa. So we'll need to have those numbers. Next, we can go ahead and see our bulk modulus, which is our EV. And our bulk modulus of water is equal to 320,000 times 6895, and that will give us, bring back our calculator here, a really big number. So I'll go ahead and count the zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have something times 10 to the 9th. We'll have 2.2, and we'll round up this one to a 1 times 10 to the 9th pascals, which is also equal to 2,210 MPa. since we said the tube is rigid, we know that it can't stretch out, it can't blow out the bottom here, it can't widen. So we can go ahead and use the same equation we've kind of been using before, where we have our volume 2 minus volume 1 over volume 1, and that is equal to length of the second one minus length of the first one over length of the one, which is also equal to the negative pressure 2 minus pressure 1 over the bulk modulus here. So we don't have any of these, so we're not going to use this portion of the equation. We do, however, we need this length too, so we need this portion, right? We need that part. And we also found our pressures, so we need that part. So we can go ahead and use this equation to solve our problem. So if we continue, we don't know L2 yet, that's what we're looking for, minus our first length is 500 millimeters, or 0.5 meters if we're converting everything into meters, over 0.5 meters equals negative, and our pressure 2 is this 11.318 minus, remember our initial pressure up here was 0, so we'll say minus 0 over, and we just solved for our bulk modulus of 2,210. So if we go ahead and plug all of this in now, we get 11.318 minus 0, not minus 1, 11.318 minus 0 stays the same. Update that, move that over so you can see it. Then we're taking that times a negative 1 to account for our negative in front here. Move this up just a little bit. And then we are dividing by 2210, and that gives us this side of the equation. Now remember, we have to finish off this side, so we get L2 minus 0.5 over 0.5 equals this negative 0.00512, on and on, that long number. So now we're going to take this number times 0.5 to move that over, which then gives us L2 minus 0.5 equals negative 0.00256. We have to add 0.5 to each side, which then gives us L2 equals to 0.4744. And remember, this is in meters, so if we want millimeters, we're going to move that over 1, 2, 3, and we get around 474 millimeters. So this will definitely change depending on how much you rounded. So you can see up here we didn't round at all. If we were to change that and round up, round all of our numbers up to say 11.32, we can go ahead and plug that in, and we'd get 11.32 times negative 1 divided by 2210 times 0.5 plus 0.5, and that actually gives us 497. So it's very important in your class of knowing if you're supposed to round to two digits way back at the top here, or if we're carrying it out to 3, because you can see that third digit makes about a 23 millimeter difference. So be sure to follow that. Otherwise, your answer, if you didn't round, will be 474. If you did round, it will be 497 millimeters. Thank you so much for joining us today. If you haven't already, please hit the like button and subscribe. If you would like to have your problem solved on the channel, contact us in one of the methods listed in the video description. Thank you so much and have a wonderful day.